All right, so I got some good feedback from the Chapter 3 review. So I'm going to make some more. So here's the Chapter 4 review. Chapter 4 is very short. We're only going to be doing the first 2 sections. I also want to point out for these videos, don't just watch this. Make sure you read through the book first. Watch some of the videos and the lessons that I already have up for Chapter 4 stuff. This should really just be something for you to watch as you're preparing for the test. Now I know there's not an actual Chapter 4 test, but you will see some Chapter 4 on the midterm, and then of course you'll see it on the final exam as well. So when you go to prepare for the midterm and the final exam, this video should help out with the Chapter 4 material. We're only going to do one question, but this one question is very long, and it has everything that you're going to need for Chapter 2. So we're going to do number 2 here. So this is on page 221 in your book, if you kind of want to read through it as we go along. Fat and Calories in Cheeseburgers, a nutritionist was interested in developing a model that describes the relation between the amount of fat in grams in cheeseburgers at fast food restaurants and the number of calories. She obtains the following data from the websites of the companies. So here we have a bunch of different types of burgers and the restaurants. We have the fat content in grams. Then we have the number of calories here in the last column. So when we're comparing two variables like this, we're always going to have those definitions back from Chapter 1. This is going to be the explanatory variable and then the response variable. You want to think of it like cause and effect. What this person is trying to figure out is, does the number of fat content in grams in a certain burger cause there to be more calories, or at least is there a relationship between the two things? Okay, so I'm going to have to go over to the next page here to get the questions, but we'll come back to this table. All right, question A. The researcher wants to use fat content to predict calories, which is the explanatory variable. So I already said that. The explanatory variable was the fat content, because that's what this researcher thinks is causing there to be more calories. The next thing, draw a scatter diagram. Okay, so I'm going to go back to the table itself. I'm not going to expect you guys to draw a scatter diagram by hand, and that's because your calculator can do that for you. StatCrunch can also do that for you. So we're going to do both StatCrunch and the calculator for almost all of the questions here, just so you can see both sides of it. I'm going to pause the video here. I'm going to pull up the calculator, and I'm going to type all of this into the stat edit this table here. So pausing and typing all that in. Okay, so I hope you're doing this at home. I hope you're doing this along with me as well. So just typing this into the first and the second column, the explanatory variable and the response variable. If we want to make a scatter diagram in our calculators, we're going to have to do some things. First thing you want to do is you want to hit second and then this Y equals button. That's going to go into the stat plot menu. So your screen should look like mine now. We only want one plot and we want the scatter plot. So we're going to hit enter on this first one. And we're going to make sure that the on is highlighted. So just hit enter on. There's a bunch of different graphs that your calculator can do. We're going to do a scatter diagram, which is this first one. So just make sure that one's highlighted. Other than that, just make sure everything else here makes sense, right? We have our x's, our explanatory in L1. That's true. Our y's are in L2. You can change the color. You can change the way that the scatter plot stuff is going to look. That's all fine. Now, if I go to graph right away, notice that we don't see anything. The reason that we don't see anything is because this graph is only going from -10 to 10 on the x-axis and -10 to 10 on the y-axis. Our numbers are from 20 to 30, and then these are in the hundreds. So we need to change our graph so that it matches. You do not have to do that manually. Again, your calculator will do it for you. If you go into the zoom button, and then down here at the bottom, you see I have zoom stat. So I'm going to arrow down to that. And then when you hit enter on zoom stat, it's going to take you back to the graph, but it's going to be centered on your your scatter plot here. Okay, so again, not going to expect you guys to actually graph scatter plots by hand, and that's because the calculator does it for you. All right, moving on to question 3, I think we're at, or C. Oh no, I wanted to do it in StatCrunch as well. All right, let me pause this and pull up StatCrunch and show you how to make a scatter plot in StatCrunch. All right, great. So I'm able to pull up, and you should be able to do this as well. You're able to, when you go to the StatCrunch button here in MyLabs, there's this option, Data Sets from Textbook. So then you just have to find that question where in Chapter 4, the review section, question 2, And then it'll pull up StatCrunch with those numbers. So if you want to do this on your own, that's how you get the numbers all typed in. Of course, you can just open up a blank one and type them in yourself as well. Okay, scatter plot. So to make a graph, we're going to go into the graph option and we want a scatter plot. You need to choose the X variable and the Y variables. We want our X variable to be the fat column, our Y variable to be the calories column. Again, there's a bunch of different options that you can play around with here. But if I just hit compute, we get the scatter plot. And notice that it's the same scatter plot as the one that we got from the calculator. It's a little bit skewed, and that's just because your calculator is a rectangular screen, whereas this is a square graph. But I promise you it's the same exact thing. Okay, now we can move on to C in the book. So question C, compute the linear correlation coefficient between fat content and calories. So if you're reading through the book, which I hope you've already done, the linear correlation coefficient is that R value, and there is an awful formula for finding that. Do not use those formulas. The calculator will do it for you. So let's go back to our calculator. Whenever you want to find the linear correlation coefficient, you have to go into Stat. You're going to go over to Calculate, and it's the fourth option here, this linear regression button. This is also how you find the best fit line, which we're going to do here in a minute. So we're going to hit enter on that. Make sure everything makes sense here. There's no frequencies, so that should be empty. Our X is in L1, Y is in L2. We're just going to go down to calculate. And we get these options. Now notice that my calculator is not showing an R value anywhere. We need to fix that. So if your calculator is also not showing the R value, you have to go through these options. So go into Mode. You want to find something that says Stat Diagnostics. So hopefully your calculator just has Stat Diagnostics somewhere in this menu. So we're just going to arrow down to it, and we're going to make sure that it's on. Some of your calculators is not going to have Stat Diagnostics in this menu, and if so, that's perfectly fine. You're going to need to go into your catalog. So if you hit Second Catalog, and you scroll down quite a bit, it's going to take forever for me to do it on this computer, but we're looking for something that says Diagnostics On. So again, this is for people that does not have Stat Diagnostics in the Mode menu. Just find Diagnostics here in the catalog. We're almost there, trying to get to the D's. So much stuff in our calculators. There it is. So just select Diagnostics On, hit enter until it says done. So now your diagnostics should be on. Now if I go back into that linear regression menu, so Stat, over to Calculate, and then this fourth option here, this linear regression. Go through the menu, just go down to Calculate. Now you see we get our R value. So this R, not the R squared, just the regular R, this R is what we call the linear correlation coefficient. And depending on the value for that R, we get to decide whether this is a good linear regression or not. Because my R value is so close to 1, I'm going to say yes, this is a positive linear relation. So as far as answering the question, our R value is this 0.9437 something. Okay, we are on D now. Does a linear relation exist between fat content and calories? And that's what I was just talking about. Because my R value is so close to 1, we're going to say yes, it does exist. Okay, so I'm going to go down to question 4 now, because question 4 is just extending question 2. Using the data and results from problem 2, that's the stuff we were just doing, do the following. So A, find the least squares regression line treating fat content as the explanatory variable. So I'm going to open up OneNote here so I can start drawing on my screen. The menu that we were just in, I'm putting my pen together just a second. The menu that we were just in, that is that best fit line. Okay, so find the least squares regression line. If I just pull up the calculator again, this y equals ax plus b, where I have my a and my b here, that is what we're going to call the least squares regression line. We always label a prediction line with a y hat. So this is going to be y hat is a times x. I'll do 13.73. I'm just rounding this to 2 decimal places just because, of course, the more decimal places you do, the better. And that's going to be plus the b. So plus 150.95. And that's it. So that's going to be the answer to part A there, the least squares regression line. Part B, draw the least squares regression line on the scatter diagram. And again, we're going to do that in the calculator. So instead of going to second to y equals to get to stat plot, we're just going to go to y equals. I just wrote down this line equation here, and I'm going to type that line equation into the first y1 here. So 13.73x plus 150.95. So this is going to graph a line, and hopefully, if this really is the best fit line, this line is going to go right through the middle of your scatter diagram. So because we already have the scatter diagram in our graph, if I go over to graph, you'll see the line that we just made goes right through it, which means that it really is the best fit line. It's a good prediction. Okay, so again, not going to ask you to do that by hand. The calculator does it for you. All right, we are on C now. Interpret the slope and the y-intercept if appropriate. Let me go back to OneNote here. This is what I care about the most for these questions. So let's do one at a time. Let's do the slope first. Whenever you have an equation like this, this is what we call the slope-intercept form. The slope is going to be that a value, the number that is on the x. So we have a slope of 13.73. Now, the definition for that slope. Slope, you probably heard before, is called rise over run. It's the change in y over the change in x. But we don't just have a generic x and y. Remember, x for us was the fat content. Y for us was the number of calories. So if my slope is 13.73, that is how much the y changes every time we change the x by 1. So your interpretations for the slope are always going to be pretty similar. Something like, we expect the calories to increase by 13.73 each time we increase the fat content by 1 gram. All right, so just the definition of a slope, this is the interpretation. We expect the calories to increase by 13.73 each time we increase the fat content by 1 gram. And then that's it for the slope. Let's look at the y-intercept. The y-intercept is always going to be the constant number on the back of your equation. So for us, that's at 150.95. With the y-intercept, sometimes it does not make sense to interpret it. That's why it says, if appropriate, here in the question. It does not make sense to interpret it with 2 reasons. The first reason is if it just doesn't make sense to the question. The y-intercept occurs when the x value is 0. Remember, the x value for us was fat content. Does it really make sense to have a cheeseburger with 0 fat in it? Probably not, right? But the other possibility is if in your table, let me go back to the table here, if you do not have any x values that are close to 0, and notice that we do not really have anything close to 0, that's another time where you do not want to interpret. So again, those 2 reasons is if it doesn't make sense for x to be 0, or if you do not have any values that are close to 0. So for us, for this particular question, I would just say it doesn't make sense to interpret since we do not have x values close to 0. If you could interpret it, I just want to show you an example of what that would look like. We would say something like, for a burger with 0 grams of fat, we would expect 150.95 calories. So again, this parentheses here is if we could interpret, that's what the statement would look like. The y-intercept occurs when the x is 0, so for a burger with 0 grams of fat, we would expect 150.95 calories. Okay, we only got a couple more parts here, so let's just quickly go through that. We are on D now. Predict the number of calories in the sandwich that has 30 grams of fat. Okay. Now that we have that prediction equation, so this best fit line here, the 13.73x plus 150.95, Anytime it says to predict something, all that means is to plug it into the equation. So what we're going to do is we're just going to plug in 30 in for the x. So we're going to do 13.73 times 30, that plus the 150.95. We'll just do that in the calculator. So it was 13.73 times 30, that plus the 150.95. Okay, cool. So this was D here. If we have a 30-gram fat cheeseburger, we would expect 562.85 calories. And that's it. So that's going to be your answer there. All right, last question. Oh, sorry, wrong button. E. A cheeseburger from Sonic has 700 calories and 42 grams of fat. Is the number of calories for this sandwich above or below average among all sandwiches with 42 grams? If you read through the book beforehand, for chapter 4 here, there should have been something called a residual. A residual you want to think of as being the error, or you can think of it as how far away a data value is from the prediction. That's what this question is asking us to find, is it's asking us to find the residual of that particular cheeseburger. There is a formula for the residual. The residual is the observed y value minus the predicted y value. Okay. The observed y value is what we get from that actual cheeseburger. A cheeseburger from Sonic has 700 calories. So 700 is the observed y value for that particular cheeseburger. We want to know, is this number of calories for this sandwich above or below average? Average is going to be the predicted y value that we get from the equation. This number, the predicted y value, we get from plugging 42 as the x back into that prediction equation. So this we get from doing 13.73 times that 42 plus the 150.95. All right, so just in the calculator real quick, I'm going to use my handheld calculator so I don't have to type it into that computer. I got 727.61. So now if I subtract these two things, I get negative 27.61. Because this number is negative, that means that this sandwich is below average. So this sandwich that has 700 calories in it is actually about 27 calories below what we thought it was going to be. Therefore, this sandwich has a better calorie content than we could have predicted. Okay, cool. So I hope that helps here for chapter 4. I know this video came out to be kind of long, but there you go. I'll make another one for chapter 5 as well.